Alright, we're back to Haskell. We did into-digit, we talked about that. And we have the ORD and character functions convert character to the corresponding numbers and vice versa. Exactly, that's Unicode. We saw that. And here we go. Caesar. Caesar cipher is a primitive method of encoding messages by shifting each character in them by a fixed number of... Oh, right, I remember, we talked about this. Yeah. Of course, when we're talking about cipher, computers, we talk about ciphers because of Turing and all that. I remember now. Right, so we can just shift them by using the numbers. Well, we don't even have to use the numbers, do we? Right, do we have to use ORD and char or CHR? Actually, that's something to try. Shit, did I install Haskell? I don't remember. Oh, I did. Nice. Right, so what if we just do a plus 2? No, it doesn't work. What about a plus b? Still doesn't work. Yeah, it doesn't work for characters because plus doesn't take that. So no, we would have to do something like this. Split it back and forth. Right. The character is not a number. You can turn it into a number if you want to. Or you can use the number feature, I guess, of Unicode. Yeah. Exactly. And we just do it exactly. It's just a map. You map it on each item in the string. Each character in the string, you shift it. You could make some what's it called? Some fancy stuff, right? Here it just shifts by a certain number, but you could probably do by indexes and shift depending on where your index is to make it harder to crack. Alright, here first we convert the string to a list of numbers. Yep, then we add the shift amount to each number before converting the list of numbers back to characters. Oh, we start with numbers, so we don't shift it back and forth. We just start with the numbers. Since we... Now we would probably shift back and forth if we wanted to do this instead of... Otherwise we would have to know all the numbers to start out with. Yeah, exactly. Start code hey to clear. Oh wow. Comes the pipe character. And the closing curly character. Interesting. Right. If you're a composition cowboy, you could write the body of this function as... Man. Right. This becomes a little bit of a mess, right? We map this whole thing on the message, right? And the message is... Wait. It's just a string, right? And we make it into a character that we plus shift, and then we make it back into a letter. Yeah, that's fine. Colgate InnoTab says, I had on the Haskell course a bugged exercise about Caesar cipher. We were given code in a book to use and make it interactive. However, the correct answer required a modification that kept spaces unchanged. Oh, oof. That's the worst, right? You don't know if it's a trick question or whatnot? that. Merry Christmas, ho ho ho. That's encoded, alright. Decoding a message is basically just shifting it back by the number of places it was shifted in the first place. That's the thing though, right? That's what you do when you crack, is that you figure out... You have to figure out what the encoding is. That's... I'm guessing computers is getting better and better at figuring that out. So then we make more difficult and difficult encoding. Alright, and it's... Yeah, exactly, it's the same. Decode, encode. Doesn't do anything. Alright, so now we'll look at data.map. Association lists, also called dictionaries, are lists that are used to store key value pairs where ordering doesn't matter. Oh, it's the same as Python dictionaries, indeed. For instance, we might use an association list to store phone numbers, where phone numbers would be the values and people's names would be the keys. We don't care which order they are stored, we just want to get the right phone number or the right person. Exactly. The most obvious way to represent association lists in Haskell would be having a list of pairs. That's what I was thinking when I saw the list of pairs, yeah. First component in the pair would be the key and the second would be the value. Here's an example of an association list with phone numbers. That's exactly what I would have thought, yeah. List of pairs. Despite the seemingly odd indentation, this is just a list of pairs of strings. Wait. I guess for someone that hasn't done programming, this is odd indentation, but I don't find this odd at all. We do this in Nix. I have this type of list all over the place. It's just not comma separated, it's just space separated, right? Or is it comma separated? I don't remember. The most common task when dealing with association lists is looking up some value by key. Yep. Let's make a function that looks up some value with a given key. Alright. I'm actually a little bit curious in how this works. Right, find key. We, yeah, the key has to, we have to check for equality, of course, yeah. Get the key, and of course we get the, it's not a dictionary, association list. Yeah, we get the association list, and we return the value. Straightforward, yeah. How do we do that? Right, we need the key and we need the list, exactly. And then we take the second, yeah. Right, we do it recursively. Yeah, that's what we do. We take the second from the head and then we filter, right, of course. We filter, so we go through the list, we iterate over the list. When we make a function here that checks if our key is the key. And if we find our key, then... Wait, how does it know? Alright. Here we define that we return the value, so then we know that we return the value. Wait. Alright, and then we call that on the... Wait. This is not... Right, filter by itself iterates over the list, so we don't have to do it recursively, because filter travels through the list, right? Note says this is different syntax from Nix, but pretty close. Yeah, it has some less syntactic stuff, I guess. But yeah, it's similar, but it's fine, yeah. Second is how it knows. Oh, right. Yeah, we returned the second. Thanks. I completely forgot about that. When we got over here, I was like, how do we know we get the V? No, here, we're calling it. Yeah. Right there. Thanks, Colgate on tap. I missed that. Node owner says that a set in Nix look like this. Alright. They call it a set. Alright. And actually, I can just copy paste it so I can show you how a set looks in Nix. Copy that and can I just paste? Yeah. They call it a set, eh? This is exactly how a dictionary looks in Python. Actually, I think it's comma separated though. Yeah, a dictionary in Python, I think it looks like this. Oh, well, no comma on the second one. Yeah, I think it's just like that. I don't remember. It was a long time ago I worked with dictionaries, or with Python for that matter. Yeah, just key value pairs. I actually kind of like this, right? It's not... Right, this thing is now defined, right? We do it for each of them. Like that. Haskell has also sets. Something tells me that Haskell sets are different from Nix sets. Something tells me that Nix sets are association lists or dictionaries. Actually, I think association list is a good name for it, isn't it? Association list, or a dictionary, or a set, or whatever. Pretty good name. Key value pairs, where you associate the key with the value in a list. Node owner says in other languages they're called dicts. Dicts, yeah, they're dicts in Python, or objects in JavaScript, or hashes in Ruby, or maps in Java. Are you kidding me? And association lists in Haskell. Nix also has a REPL. I don't remember what that is. REPL? I've seen it before, but don't remember. I don't know if it's me being bad at name or I just don't know what it is. Could be either way. Right. Read, eval, print loop. Nice. Ray loses and disappears. Okay. Score, right? Isn't that what Lisp is like super hyped about, that they have the REPL? That's why one of the reasons why the Emacs guys really love Lisp, maybe. It's basically an interactive shell. It's what you're using now for Haskell. Right. Right, so the REPL is just Nix shell. Is that the REPL? Interactive shell? Man, the nostalgia is real. This game, amazing. Alright. Where were we? Right, we checked that. It's pretty simple. The function that takes a key... Wait, pretty simple. The function that takes a key and a list filters the list so that only matching keys remain. Exactly, yeah. Gets the first key value that matches and returns the value. Yeah, so it doesn't go through the entire list. Wait. Does it? I don't remember filter. No, it gets the first value. It's what it said, yeah. So filter only takes... No, wait. Is that really what filter work like? Right. filter Haskell. Filter function. How filter function works. Wait, what is this? This is not the page I was expecting. I was expecting something else. Right. Yeah, it returns a list. Yeah. Uses a predicate to filter the list of the data structure and return us the new data structure. Yeah. So why does this only return the first one? And not the entire... Not all of them? Not only says Citra emulator is available for Nix, so you can play the remaster of Ocarina of Time and Majora's Mask. I've never played the Majora's Mask. I remember you mentioning in the Citra emulator. That would be something. Also, Super Mario 64 is packaged for Nix. They're just there. Right. I need to check this. What if we go to Nix? os.org and we go over here and we search for Ocarina of Time. That really? No. So you have to go for Citra, is that it? Oh, it has some Haskell packages. Oh, right. Say, well, is that a big difference? Super text card. First person Super Mario Bros. Super Mario 64 port based off the compilation. There it is. What about Zelda? Zelda-like action RPG game engine, Solaris. Alright, so you would have to get Citra then. Open source emulator for Nintendo 3DS. Nice. I mean, I think I have both the games on my 3DS. I don't know how to put them in the computer, but... Right, the head. Sorry, we got a little bit off track there. The head is how it only returns one thing. Let's see here. What is it that we're filtering really? We're filtering the entire list though. Right, yeah. We only return the head. That's what's going on. Right. Yeah, I see it, yeah. SM64X. Yeah, there's no Zelda PC port yet. They're working on it. Nice. Alright, but what happens if the key we're looking for isn't in the association list? Yeah, we didn't call maybe, did we? Here, if a key isn't in the association list, we'll end up trying to get the head of an empty list, which throws a runtime error. Yeah, however, we should avoid making our programs so easy to crash. So let's use maybe, the maybe data type. If we don't find the key, we'll return nothing. If we find it, we'll return just something, where something is the value corresponding to that key. Right, how does that work? We have maybe v, so we return just the v, or yeah, exactly. Else find key. Ah, there we go. That's where we return nothing. I was wondering, where's the nothing? It's our edge case. Yeah, our edge case... No? Shit, I don't remember. What did they call this? Is this the edge case? It's where we're done. I don't remember what they called it. Another one says you asked if it matters that much to switch to unstable on the search. It's about 6 months worth of mattering. I mean, I really learned yesterday, right? I learned firsthand that you do want to be on unstable. I mean, it's bad naming conventions because the stable is just trash. Yeah. Couldn't get the stable to work, right? Then I switched over to unstable and voila, it just works. It is edge case, right? I didn't remember what it was called. Edge case, and we find the key. If the key is equal to k, then we return just v, else we find the key on the rest of the list. Oh yeah, I like this. This not only do we use maybe, so it's safer. I find this to be way easier to read than this. Yeah, I kind of feel that the function composition, when you have long functions like this, makes me want to scratch my head. What's going on? Look at the type declaration. It takes a key that can be equated, an association list, and then it maybe produces a value. Sounds about right. It does indeed. This is a textbook recursive function that operates on a list. Edge case, splitting a list into a head and a tail. Recursive calls, they're all there. Yeah. This is the classic fold pattern. So let's see how this would be implemented as a fold. Oh shit, I don't remember the folds. What was the benefits of using folds? Instead of using the classic recursive call, why is the fold? What's good with it? Note says if you had waited like a month, you would likely have had a better experience with stable because the new release is coming soon. Oh, so it's reaching end of life. The stable. Actually, that would make me assume the other way around. The longer a stable version has been a stable, right? Like I would assume that 20.09 is more stable than 21.05 because they've had time to stable it up. Right, fix all the potential kinks, just like I would have assumed that all the potential kinks on 21.5. Maybe that's not how it works. Oh, that's the channel. Right, when the channel is published, it is published. It's the one you have. When you go to next channel update on like this channel, does 21.05 get updated, right? They get security patches and whatnot, right? This what they do get updated as well, right? They backport certain things, but overall it's unchanged, hence stable. Yeah. Right, so how do we do that as a fold? I don't remember the value of a fold. Right, they still have the same, yeah, they have the same type definition. Find key, we fold right. Why do we fold right? Oh, because it's a recursive function? I don't remember. Right, we have the list. Actually, it's easier to just, here we go. We have a list. Hello. Fold right. It's this way, right? That we put O or whatever we do with O as the accumulator. We build an accumulator, and then we do something with O as the new accumulator, and then we do something with L as the new accumulator, and then we do something as L as the new accumulator, then we do something with E as the new accumulator, and like that. That's the fold right? And fold left is just the other way, that we start folding. We start the accumulator over here, and then we do it on AG and whatnot. Colgate in on tab says yes. Nice, so I got it. I did remember how the fold stuff worked. But that surprises me. Why would we do... Oh, right. We need to do fold right. In case of... No? Why don't we do fold left? Does it matter? I'm thinking infinite lists, but you can't call fold right on an infinite list, so it doesn't matter, does it? We'll see, we'll see. All right, we make our lambda function, right, for on our pair and our accumulator, right? So if the key is equal to our key, then just return v, else a new accumulator, and in the very end, yeah, we return. Wait, where does the nothing come from? Is it because oh man, the syntax, I don't remember here. Why do we put the nothing over here? I mean, I guess we do the fold right over all this place, but... Right, how do we get out of this and reach the nothing? Colgatino tab says, because if there are no hits, we return nothing. Oh, that's it, right? That's what's happened. We're folding this right, and then when nothing well, that's just how fold right works. Yeah, right. T fold right. That's just how it works. We have a foldable. We take the function exactly. And that's the function. Wait. And then we return the B, which is our that's our accumulator, right? Shit. No, I'm confused. We take the well, this didn't help. We have... Oh, your tab just restored its tab. It's crashed. Right. Emerson shell. Like this one. Oh, we're back here. B is the type of accumulator. Yeah, that's what I thought. That B is the accumulator, right? So we have... Oh shit. Let's see the list again. Alright, so... A is... What is A here? It's a function that takes something and then we do it to... We return an accumulator. What else are we taking here? Right. Oh man. the more I look into it, the more confused I get. I get this feeling where I understand what's going on up here, and then we do this fold thing, and I'm just completely lost. A is... wait. B is accumulator. A is what type foldable is. Oh, so foldable. This is... T is the list. And A is whatever is in the list. So in our list here, the string is our T, and our A is our characters, and B is our accumulator. While here, in this one, A is a pair. It's our KV pair. And our accumulator is the V, right? That's what we return. We return a V. Or, no, it's our V is a maybe. It's maybe V. Gotta be straight out, yeah. Or, like in our foldable, that's the equivalent to B. We just decided that B is a maybe V. Yeah. Let's see. Nix does folding too, I think. I have no idea how it works. It's... It's just you iterate over a list. It's in the name, right? You fold it. You do a function, right? Here on age. And you create a new accumulator and you do the function on E. Right, so kind of fold it like this. We fold it all into each other. So wait, oh, sorry. That's not how we do it. We fold age with a function into E, and then a function into L, and then a function like so. We fold it all, and then we end up with just a single value. Whatever that value is, can be anything, right? We can do count, we can do... It doesn't have to be, right? That's what it says. It doesn't have to be the same type. You can do whatever you want to, right? You can just count how many items there is in the list, right? That's probably one of the most simple foldable things we could do. Right? Let's see if we can do that. If we fold R... actually, let's fold left. For whatever reason. And it takes... Right, it takes a function where we take... what do we say? What do we say? We say... If it's greater than A. There we go. If it's greater than A... Wait, no, we need a function. Yeah, we need a function. So we do the function for... X, like that. And we say... Oh shit, this becomes a problem. Right, we have a list. And we just take XS and we do if X is greater than... Actually, let's do it on numbers instead. If X is greater than... Smaller than, it says even, is smaller than 42. Then just... No, we don't need a maybe value here. Then X else... Shit, I don't remember. No, since we're working with recursion and in this... I really like the idea of just we have a list of things and we fold them into each other. That's what we're doing. I feel like I've been up all night working on NixOS, so making a fold list today, I don't feel up for it. Yeah. I kind of just felt like I lost track of what was going on, so I'm sorry. Yeah. Colgate types is and B is a maybe pair. No, it's a maybe second of a pair, right? Yeah, in here, it's maybe V. It's not maybe pair, it's a maybe second of a pair. Yeah. A is KV, maybe B is maybe exactly, yeah. Colgatinot have noted that I called it bigger than, greater than when I used a smaller than before, indeed. Colgatinot says, we were taught Piki Pista Painempan Su Aiki Surempan. That's definitely my perfect Finnish pronunciation, yeah. As a mnemonic. It roughly translates to, as the thorn pricks the smaller, the open mouth the larger. Yeah, I have the same, right? It eats it, right? It's just that, right? If we type it out, right? On the left side it's smaller, on the right side it's bigger. I mean, you see it right there. And just get confused by those things for whatever reason. Who knows? Alright. I'm curious about the note here. It's usually better to use folds for the standard list recursion pattern instead of explicitly writing the recursion because they're easier to read and identify. Well, that's just like your opinion, dude. It's your opinion, dude. So far by these 3 versions, I find this one to be the easiest to read. Today, anyway. Maybe it'll be easier to read when doing some more folds, I guess. Everyone knows it's a fold when they see fold R called, but it takes some more time thinking to read explicit recursion. That's actually a very valid point. Right, we have to, right, to know that this... No, I disagree. Just like everybody knows how fold R works, which I don't, but kinda. I've got a hunch. At the same time, we know that, oh, this is a typical start of a recursive function. Because we define our edge case on a list. And then we can check, right, a key. And we can just skim through. Oh, we do have a key here. Oh, find key, sorry. We have a find key call here. So, I don't know. Depends on how you look at it. Maybe. Find Penny in the phone book. Yeah, they all worked. Works like a charm. If we have the girl's phone number, we just get the number. Otherwise, we get nothing. We get nothing. Yeah. We just implemented the lookup function from data.list. If we want to find the corresponding value to a key, we have to traverse all the elements of the list until we find it. Yep. The data.map module offers association lists that are much faster because they're internally implemented with trees. Right, we haven't even looked into trees yet. And also provides a lot of utility functions. From now on, we'll say that we're working with maps instead of association lists. Are you kidding? Well, actually, wasn't it one of the other places called maps as well? Oh, sorry, I just remembered. I saw now that NodeRunner said a couple of minutes ago that Splitgate just had an update where they added work in progress maps to a special game mode. It's neat. Oh, right, I'm assuming that these work in progress maps are like... what's that called? Early access? No, right? Where they give you access to the maps, but they want feedback, right? To improve how the map works. Crowdsourcing feedback. Yeah, seems like a good idea. Do you have a strong grasp on Lambda functions yet? Alright, a Lambda function is just a function that we put anywhere. So we would say that, where we had a Lambda function over here, right? We could say that the Lambda itself is just in place of a named function. So, since we're defining the function, these are the things, the input, if you like, to the function, right? We give the lambda, and then we just give all the input space separated. Well, it's a curried, so parameters. Here we go. Yeah, these are the two parameters to the lambda function. Let's skip the curried function thing. It's just two parameters. I'm happy calling it two parameters. And this is the actual function body, right? That's a lambda function. So it's just, I would say yes and no to a strong grasp on lambda functions, because I don't have a strong grasp on functions. Oh man. But it's just a function that we put wherever, with a no-name function, one-off. Without a name. It's a useful thing to have in your code, for sure. Right. Where were we? Somewhere here. Right. Yeah, that was what I was looking for. We were looking at... Where was it? In other languages, they're called dictionaries. Oh, right. In Java, they call them maps as well. So in Java and Haskell, they call them maps. I don't know how I feel about calling them maps here, because we have a function called map. And then we have a data type called map as well. And are they the same? I don't know. A lot of utility functions. From now on, we'll say we're working with maps instead of association lists. Why do they do that? Why do programmers do that? Why not just call it like ass list? There you go. Call it an ass list. Don't call it a dictionary. Don't call it a map. Don't call it a set. Call it an ass list. There you go. It's just short for association list. Or, better yet, just call it an association list if that's what it is. I'm confused. Colgatinotype says, I was thinking it was that lambda that was throwing you off, but I guess it was fold right after all. Oh, it was both, right? There was a lot of things going on, and right, keeping track of the fold right function within the fold right function is too much for my too much complexity. Oh, I like that node owner. Just call it a key value pair. Oof, I like that one, yeah. I thought it was funny with the ass list, but yeah, a key value, well, a list of key value pairs. But because it is a list, after all. They call it dictionary, but it's still just a list of key value pairs. Colgatinotype says, so we can map over maps? I guess I suppose that... Alright, so he's holding a map. I agree with this smiley face, eh? Right. Why? Let's try and be generous here and say, why would we call it a map? Because it's similar to the map. We map a key on a value. It's kind of similar to what we're doing, right? We're mapping a key on a value. I don't know. Right, because data.map exports functions that clash with the prelude, and data.list ones will do a qualified import. Import qualified data.map as map. Right, gotta remember that qualified. Put this import statement into a script and then load the script via GHCI. I wonder why he asks us to do this, because this has just worked every time. Qualified data dot map as map. Hey, this just worked every time. Alright, the from list function takes an association list in the form of a list. Alright, from list takes key value pair, a list, alright, and returns a map with the same associations. Oh, right, we create a map from a list. Right, because that data structure, it's not, yeah, it's an improvement. It's a back-end improvement, stuff that happens behind the scenes that makes it more efficient. So if we want to work with key value pairs, lists of key value pairs, we're gonna have to call them maps in Haskell, because actually we don't have to. We could import it as something else. We could import it as list. Right? And there we go, then we have as lists. So they don't have to be maps, but that's just extra confusion, isn't it? Oops. ACI map from list. Right, and they just look the same. Yeah. They look completely the same, but under the hood they are not. If there are duplicate keys in the original association list, the duplicates are just discarded. This is the type signature of from list. Yeah, we just go back and forth, right? Have an ordered key, yeah. We have a associated list, but then we get a map.map out of the key and value. Yeah, exactly. The keys and values. Wait. Yeah, that looks fine. Decoding type says we could make our own data type for it. Yeah, but why bother, right? That seems like a lot of work. When someone else has already done the work, right? It says that it takes a list of pairs of type key and value, K and V, and returns a map that maps from keys of type K and V. Yeah. Notice that when we were doing as lists with normal lists, the key only had to be equatable, they're belonging to the EQ type class, but now they have to be orderable. That's an essential constraint on the data.map module. It needs the keys to be orderable so it can arrange them in a tree. Right, so the keys have to be unique and orderable. Well, the values can be whatever. That makes sense. That makes sense anyway, right? Because we only want one key, right? If we get 2 keys, that would be a little bit broken, I think. You should always use the data.map for key value associations unless you have keys that aren't part of the ORD type class. Okay, yeah. Empty represents an empty map. It takes no arguments, it just returns an empty map. Insert takes a key, a value, and a map and returns a new map that's just like the old one, only with the key and value inserted. Yeah, I like that. Right, we can implement our from list by... Wait, we can implement our own from list by using the empty map insert and a fold. Watch. Alright. Fold right. Oh man, another fold. This is the function. Alright, and for each accumulator, we will just insert the key and the value in the... Wait. Alright, we have an empty map. We insert the key and the value in the map, and shit, yeah, I'm confused what the accumulator does here. We go to the next step, so no, the key, the accumulator starts out as an empty map, right? And then we map these two, and then since we're folding, then we go to the next value. This is the new key value pair is the new accumulator, and we insert it to our current map, and that's how we fold over it. So we don't exactly in this fold we don't do anything with our list, right? The only thing we do is that we insert them. We just iterate over our list and insert them. That's the only thing that we do. And our accumulator is just keeping track. It's just keeping track of the current value. Like in normal, sorry. Damn it, I did it again. In, oh shit, I don't even remember what they're called. The other types of programming languages. We use indexes to decide where we are in the list. Here instead we just keep track of what value we have. And we know implicitly that, right? Since we're doing recursion, the previous value poof goes up in smoke when we get the new value, right? If we go from yeah, that's what we were talking about before. Yeah. Actually, maybe we should do the example a little bit more like what we're actually looking for. Right, H1, oops. H1, sorry, that's... Right, I'm just making an example here. Right, and then we have, oops, E2, and one last. Right. Right. Oh, sorry, that's... Whoop. Right, here is our input. So what we say is that we create our accumulator, which is just an empty map. So it's an empty key value pair. And then we iterate over our list, since we're calling folder RR. We come to the first one. This is our new accumulator. On it, we call map insert, the key and the value. We insert it to our empty map. And what happens next is we're done with that one. And we get our new accumulator. And our new accumulator, we do the same thing, right? We do the exactly same thing. This is now our accumulator. We take the key and value pair and we insert it to our previous accumulator, which is no longer an empty map. It was our L3 value. So we insert that. So now we have both of the values in our map, and we do it one more time, and boom. Right, and fold R is just, it just ends when the list is empty. Is that just what happens? Am I doing it right? Imperative. No, that's the new KV. Accumulator is a map. Yeah, it becomes a problem because the accumulator is a key value pair. But so is the part of the list. It's a key value pair. Both of them are, right? We take the key and we take the value and we insert them, right? So it's, no, key W. What do you mean, Colgate on tap? What am I misunderstanding? You're saying that the accumulator is... Oh, right, it's... Yeah, it's not the key value pair. It's the map. Yeah, so, like, this is our empty map. That's our accumulator. And we insert the key value in our map, right? So we insert the first... Like, there's nothing here, so... We insert our KV, and then the next time, the new, right, the new accumulator, this is the new accumulator. So then we insert the next key value, and this is our new accumulator. Then we insert our new value, and this is our final accumulator. Because, well, our list is over with. Is that it? So the accumulator is not... It's the entire output. Yeah, the accumulator is what, when we finish with our fold, that is what we spit out. That's our return value. Noteowner says, here's how I would get your bot working fast. For each package you'd install with pip. I did not install any packages with pip. And I already have fixed the packages. Right? The only thing I need to do is set it up. Right? My system is prepared for the bot. Yeah, I have the Python packages installed already. Yeah. Search for a replacement in Nix packages. That's what I did, yeah. And then just run a command like nix shell p. Oh, that would have been the way to do it. Yeah, I gotta start using the Nix shell more because of the magic. The magic is amazing because every time you want to try something, doing a full NixOS rebuild switch is... I mean, it's a pain. It's a pain. So it's better to do a Nix shell. And just add the packages. Create a shell with the packages that you want and make sure that those are the ones that you want. Luckily, it's very easy. I only have 2 packages that I needed to install. It was, I think, requests and SQLite utils. Actually, I'm not so sure. I might need a sockets package, module, whatever. So I can try that. Or actually, I am going to try that. Colgate Tab says there is a from list at the beginning because it is a map. Sorry, that didn't help. Other than that, you got it right. From list. Here it doesn't, like, yeah, we did our own from list. This is our own from list. Other than that, you got it right. Yeah, so we just have one data structure and we put it in another data structure. That's what the function does, which is a fairly easy function to do, right? That's not too rare a thing to do that you get. Yeah, you have something and you want to turn it into a different data structure. Just to make it easier to work with. That happens quite often, doesn't it? Yeah. Nodeowner says you can do a shell.nix configuration file in the Git repo for your bot. It's like a nix config for the environment that you want to... Right! So that's how the shell.nix thing is, right? If I have it, and then I can call... So shell.nix, what it does basically is create a nix shell, right? Yeah. So you can, instead of just doing a one line shell, nix shell -p, you can just do the mini configuration in the environment. Right. Specifically, right? I'm happy having a global installation of requests for Python because requests for Python is amazing. I love it. I actually use it for one of my own scripts. And SQLite utils, I like that. I use that in some other places as well, so I'm happy having that. But maybe it would be better to... No, even if I have them globally in my entire system, it would be a good idea to create an environment and put them in specifically because that is a reproducible environment. Yeah, then that specific directory becomes reproducible in a nix way. I like that, yeah. Colgate tab shows that, yeah, you've got a list of pairs, and from list is a map of pairs. Yeah, that is what threw me off a little bit, right? Because a map of pairs looks exactly the same as a list of pairs. Wait. Wait, a map of pairs? Is that how it works? I thought... No. A map is a list of key values, so you don't need pairs. It's not the same. The map has from list. Oh, you mean I missed out on this? That's part of the data structure. It's important to point out that that is part of the data structure. It's just like a prefix data structure thing. That's weird. Hello, Melanol. Nice to see you again. I was gonna ask how you are, but you already answered. Right, the butt hurts? Oh, that's too bad. I took a big project, expected to finish in 3 days. Will most likely take 10 days. Oof. Crappy Alibaba terms. Wait, almost all require Googling. Oh no, even with machine translation? That's awful, yeah. Don't even know why I translate if I have money for 2 years. I mean, you get money for 3 years. Melanol, yeah. Hello, Cass. Nice to see you. I have a green screen, yes, I do. I'm in here. Inside the text. I'm inside the text, right here. Inside the text. Right. Just Alright, if we only have this thing and nothing else, if we only have this, it is a list of... No, it's a list of pairs. This is what this is. But this is a map of a list of pairs. Is that what you're saying? So a map is not necessarily... I thought my understanding from how the text does it, right, is that an empty map... Oh, right. I thought it had to be a key value pair. Like that it had to be a pair. But that's not necessarily how a map works. You could have any kind of thing in here. Is that what you're saying, calling it in on tap? So the map is not equivalent to the Python dictionary or the AS list. Yeah, the AS list is just one way of doing a map. Melanol says the butt hurts figuratively. Nice. I thought you had like what's that called? We say in Swedish we call that like a... I don't even remember. Taste for wood? Yeah. Wow. That translated very funny, yeah. That means that our butt hurts. And that's not a taste for wood, a wooden taste. Yeah. Which is kind of hilarious when you translate it. I've never thought about that before, but yeah. That's if the butt hurts, right? Not figuratively, but literally. It's like you've been sitting on like a wooden bench for a long time and your butt starts to hurt. But yeah. Wood taste. Hilarious. Oh man. Cass says, yeah, damn, I'm jealous now. Aha, nice. Colgatinotap says it needs a key value pair. Okay, so it needs a key value pair, but it also needs this. Just to help us out and to make sure that we know that this is a map, not a list of pairs. Melanol says I'm actually expecting a butt pillow. Nice. Good stuff. Alright, now that Cass showed up and Melanol showed up, like, there's only one thing to do. It's to piss off and eat lunch. Yeah, so it was nice seeing you, but yeah. Thanks for hanging out today. Hopefully we'll get a bot working for tomorrow and some other stuff. If I'm not too exhausted and just fall asleep and sleep until tomorrow. Alright, but we'll keep doing the... Actually, maybe we'll do a little bit of repetition on the from list. Go from here tomorrow? Maybe, we'll see. Alright, thanks for hanging out, and see you next time, yeah. Cheers.